Actually, the second time I'm doing this video because apparently I wasn't recording the first time. So that's why there's some notes and scribbling already over on it. Apparently I didn't erase everything from number 2 yet already either. So let's just do this. Okay, so I'm going to again go through these very quickly, pause or slow down or rewatch as needed, and try them first. Okay, 3 to the negative 4. Using our properties of exponents, 3 to the negative 4 we know is the same thing as 1 over 3 to the positive 4. And that's a property of exponents, because when we're raising it to a negative power, we're actually dividing instead of multiplying. Okay, so 1 over 3 to the positive 4, I don't know off the top of my head what 3 to the 4 is, but I do know what 3 to the second power is, and that 3 to the second power times 3 to the second power is 3 to the fourth power. So 3 to the second power is 9. 9 times 9 is 81. And so my answer is 1 over 81. And you could put that in a calculator and get your decimal, but it would be ugly. 12 to the sixth power divided by 12 to the second power. We have the same base, 12. And so if we were to multiply this out, we'd have 12 times 12 times 12 and divided by 12 times 12. And some of our 12s are going to cancel out. So what we do is we subtract our exponents. That gives us 12 to the 6th minus 2, which is 12 to the 4th power. And you could put that in a calculator and get a huge number, but you don't need to. That would be a good answer. Number 3, we want to write this in standard form. It's in scientific notation. We want it in standard form. These little waves under here was me counting. 10 to the 9th means we need to move 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write this out as 1, 0, 3, 9, 5, and that was moving 4 times. And that means I have 5 more times to move, and I just fill those in with zeros. And that would be standard form. Rather large number. 1,039,000,000,000. 500, no, that's 39 million. 1,039,500,000. Okay, number 4, we're doing the opposite. We're going from standard form to scientific notation. If we count how many decimal places we needed to move, and remember that scientific notation has to be a number between 1 and 9 to start off with. So we can't have 70 and we can't have 0.7. We need to have 7, and it's going to be 7.01. because that's the next 2 numbers. And we had to move from where the decimal place was 1, 2, 3, 4 times. So it's going to be times 10, not to the positive 4 though, because that would give us a bigger number. We want a pretty small number. It's going to be to the negative 4, because we're going to go this way if we were to convert it back. So 7.01 times 10 to the negative 4. Number 5. Again, we can use the same trick that we used in number 2. We have 10 to the power of 9 divided by 10 to the power of 4, and that is going to give us 10 to the power of 9 minus 4 is 5. So we can rewrite this as 7.86 divided by 3, all times 10 to the power of 5. 7.86 divided by 3. I recommend putting that in a calculator, and that will give you 2.62 times 10 to the 5th power, and that's nice. And in scientific notation, the 2 is between 1 and 9. Okay, very quick. This is all review. I hope that you remember it. If you have specific questions, I do have office hours arranged to talk to me about them, and we can go over some problems in practice.